Hey everyone, now we will take a look into the online banking portal and how the online banking portal will invoke IdentityShack for biometric authentication. So this what we see on the screen is a very simplistic representation of a banking portal. The look and feel of the banking portal is subjected to the business functions that the bank wants to provide online, as well as the customer's need, or like whichever way the customer wants to see the banking services. So in this portal, what we see are few options like account management, loan management, bill payments, digital wallet, etc., which are potential banking functions that can be actually enveloped within biometric authentication. Like these are basically like banking functions which might be critical for the business of the bank. We will talk about in details more about like what are the other critical banking functions which the bank can envelop within IdentityShack in the business case video. But before we click upon authenticate using IdentityShack, we will talk about two very important concepts. One is that of deep linking, another is that of intent filter. Deep linking is a URL that uniquely identifies an intent within the app. So once that link is provided, the web browser will try to find out the relevant intent within the app that actually should handle this request, or it will redirect the request to a different URL that usually is the installer for the particular app. Intent filter is whereby we declare the deep linking URL. So it has got, it's part of the Android manifest.xml file, whereby we embed the link in the scheme and the host properties of the intent filter. So let's click upon authenticate using IdentityShack and let's see. Now that we have clicked upon the verifying biometric part, now that we have clicked upon authenticate using IdentityShack, we are redirected into one of the intents of the app, which is explicitly made for handling online transaction requests. So this particular intent will do the biometric authentication along with generation of cryptogram. So once a user has been, account holder has been uniquely identified and authenticated, a request will be sent across to the bank containing the context of the transaction. The context can be loan management, account management, bill payments, or any specific transaction criteria that uniquely identifies the transaction. Along with the context, several other parameters will be sent across to the bank, which will help the bank to identify if it's a legitimate transaction. If it's a legitimate transaction, the bank will generate a one-time password. This one-time password, along with the keys that were generated during the registration process, along with any offline keys sent by the bank through bank self-service portal, will be used to generate the cryptogram. So let's click upon confirm fingerprint scan. So now that we have clicked upon confirm fingerprint scan, we will provide our fingerprint, and this will lead us to the confirmation page whereby we can see that the loan has been submitted along with the cryptogram. So the cryptogram we see over here is an ASCII representation of the actual cryptogram. Since we wanted to represent the cryptogram in web browser, we have to use URI encode, otherwise it will be a bad request. The original cryptogram was a non-ASCII character generated from the transaction details, as well as the one-time PIN and the keys that were generated during the registration and stored in the Android app's secure key store. Along with this, the bank can also send offline keys. So that's it from now. Thank you, everyone.